Hi, today in class we worked on how to solve for where graphs meet. And this is done by either setting equations equal to each other, or by looking on a graph and seeing the intersection of the two graphs and finding the point from there. So we'll go over what we did in class today, and hopefully this will clear some things up for you. So the first one says, given the following equations, determine the x value that results in an equal output for both. And now my output is basically my y. My input is my x. So the first thing I'm going to do here is I set both of them equal to each other. Plus 6x plus 8. My next thing is, my goal is always to have my leading coefficient to be positive. And in this case, my leading coefficient, or my term with the highest degree, is x squared. So in this case, all of my terms are going to be on the right side of the equation, and I'm going to set it equal to 0. Doing this really helps me understand where I'm trying to get all of my terms to. So my first thing, I'm going to subtract 3x to move it over to the other side. And then at the same time, you can see I have to add 2 to both sides of the equation. So in this case, 0 is equal to x squared plus 3x plus 10. So at this point, I have a quadratic equation, and so I can either solve it by using maybe the x factor, which is the easiest way, or by using the quadratic formula. So let's try the x factor first because it's easiest. And I have the x factor here. I have a times c is going to be 10, and then b is going to be 3. And my factors of 10 are 1 times 10 and 2 times 5. Now, either both of my factors have to be positive or both have to be negative because they have to equal 10. And in this case, if I put both of them positive 1 and positive 10, that's going to equal 11. Negative 1 and negative 10 is going to equal negative 11. Negative 2 and negative 5 is going to equal negative 7, or 2 and 5 is going to equal 7. So I cannot factor it using this, the x factor. So I'm going to the next step is going to be the quadratic formula. And then c is equal to 10. And so I'm going to say the opposite of b, plus or minus, b squared minus 4 times a times c divided by 2a. And at this point, it's just simplifying my equation. So I have negative 3 plus or minus the square root of 9 minus 40 over 2. And because a is 1, I should put a 1 there. And then that's going to be equal to negative 3 plus or minus square root of negative 31 divided by 2. And then I have a negative underneath my square root, so my final answer is going to be negative 3 plus or minus I times the square root of 31 divided by 2. And it just asked what my x values would be. So when my x value is negative 3 plus I, the square root of 31 divided by 2, they're going to intersect. And when x is negative 3 minus I times the square root of 31 divided by 2, they will also intersect. So moving on along to number 2, which is one that you needed to do by yourself in class today. It says graph and solve. I'm not going to graph it, I'm just going to solve it, for when f of x is equal to g of x. And so in this case, f of x is x squared minus 1, and g of x is x plus 1. So again, I want to have my leading coefficient as positive, so I'm going to keep all of my terms to the left this time, and I want 0 to the right. So to get negative 1 over there, I'm going to subtract negative 1, or subtract 1. And then to get rid of the x, I'm going to subtract x. And notice I didn't put it under the x squared because those are not like terms. And I have x squared minus x minus 2 is equal to 0. And now I have it in the form where either I can use the x factor or the quadratic formula. And I know in class today, people did either or, and it's fine. You'll come up with the same answer. A times c is going to be negative 2. And then b is negative 1. So I can see I can have negative 2 and positive 1 as my factors that are going to multiply together and get negative 2. And my x leading coefficient is just 1, so factored out, it's going to be x minus 1, x plus 1 times x minus 2. So that is the answer factored out, but I still haven't solved it. So in this case, I have to solve for x, so x is going to equal to -1, and x is also going to equal to 2. But I have to go even further because you have to give me the point where it intersects on the graph. And so for f of -1, I'm going to punch in -1 squared minus 1. And then for f of 2, I'm going to set it equal to 2 squared minus 1. So when x is equal to -1, f of x is going to equal to 1 minus 1, and so that's equal to 0. And then 4 minus 1, and that's equal to 3. So my points of intersection are -1, comma, 0, and then 2, 3. So that tells me that I'm going to have an intersection of my two graphs at -1, 0, and 2, 3. And looking at the degree of my polynomials, you can see, well, that doesn't give me my roots or anything, but you can definitely see that that is the solution to the problems. Number 3 on our paper we did together as a class, but we'll look at it again, and it says the graph shows the cubic function f of x and then the exponential function g of x approximate the solutions to the equation f of x is equal to g of x. So basically where these two graphs intersect. And there are 3 points. And the first point appears to be at -1, -5, positive 5, -1, positive 5. The second point here looks to be maybe at 1, we'll just say 1, 2, and it says approximate, so that's fine. And then my next one is going to be at 3, -1. So those are my 3 points of intersection. And if it's graphed and I can read it, it's much easier to see the points of intersection or where the two graphs meet. Number 4 you did on your own today. And so I'm looking for where they intersect. So I'm going to have 3 spots again. And I'm just going to read my graph. And it looks like at -7 and -5 is one of my answers. Maybe 1 and 3 is another. And then it looks like maybe 5.5 and 7, or 7.5. So 5.5 and 7.5. And it's fine. It can be approximate. That's okay. So it's approximate. So moving on along to number 5, we did in class together. And first thing, it tells us to solve where f of t is equal to g of t, and so I solve for my intersection points. And my intersection points here appear to be -2 and -1. -2, -1, and then my other point of intersection appears to be at +3, 4. Okay, so very easy to do just by reading the graph. The next one, I'm going to use some colors here so you can visually see what I'm talking about a little bit better. And it asks you, okay, what part of the graph is f of t greater than g of t? So I have 2 intersections, so I've got like 3 intervals here. So I have my first interval, my second interval, and my third interval. And I'm going to see in which interval is f of t greater than g of t. So my first interval consists of this, and I'm looking at my y values. And all of my y values are greater for g of t than f of t all the way up to the point of intersection. So none of that interval will be greater than g of t. But if you look at this next section, section 2, you can see that the green graph, or f of t, is bigger than g of t, or the y values are larger than the g of t. So in this interval, actually, f of t is greater than g of t. And then looking over here at this interval, you can see, again, the f of t, or g of t is now greater than f of t. So I want this portion of my graph right here is my portion where f of t is greater than g of t. So at this point, I just have to figure out what that interval is, and of course that point starts from -2 to 3, f of t will be greater than g of t. The next one is finding the values of f at 0. So this point right here, I think I'll use this, okay? And that value of f of x at 0 is going to be 1. And then I'm going to add that to the value of g of x at 0. And that value is -5, just reading it from the graph. And so when I add those together, my answer is -4. The next one, it asks you which is greater. Is this point greater than when the red graph when it's on -3? And that would be right here. And you can see that this point at g of -3 is going to be greater than this point at f of 0. So g of -3 is equal to, it appears to be 2, whereas f of 0 appears to be at 1, and so 2 is greater than 1, so g of -3 is greater than f of 0. The next one that we looked at is we have two graphs again, and we have one graph of the car and how far the car travels in a certain amount of seconds, and then we have another graph of a motorbike. Okay, so if you read the graph, the distance along the road in meters is represented by the y value, and the time in seconds is the x value. So it says find the distance between the motorbike and the car at t is equal to 0. So that's going to be this distance between there. And 10 minus 0 is 10. So the distance at 0 from each other is 10. The next one is at 1 second. The distance between the two is from here to here. So it's 20 minus 5. And that distance is going to be 15 meters. And then at 2, the distance between the two appears to be maybe close to 5, 10, maybe 10. So that would be 10 meters. And then at 3, it appears that maybe the distance is like maybe 12. No, maybe 7. Sorry, 7 or 8 meters. And then the distance at 4, it appears that that's where they intersect, so that's 0. And then the distance between the two at 5 appears to be 5, 10, 15. So 5 is back to 15 meters. So that's how you do that one. Now, part B of this asks which vehicle is a further distance down the road at t is equal to 1 second. T is equal to 4 seconds, and t is equal to 5 seconds. So at t is equal to 1 second, it appears that the green car, so the car is going to be further down the road. At t is equal to 2 seconds, it appears again that the car is further down the road. Okay, and then we'll do 4 seconds, and it appears that they're equal distance. They're equal because the graph intersects. So, and then at 5 seconds, it appears that this is the point where the motorbike is further down the road than the car. So my answer there is motorbike. So hopefully that helps you a little bit understand about how to graph and solve for solutions, or how to solve the solution algebraically.